Hi, this is Andy Grove, and this is a quick demo of Ballista running a distributed query. So in this demo I have a terminal session open on my desktop. I have 4 tabs, and we're going to run a scheduler process in the first tab, then 2 executor processes in the next 2 tabs, and then the benchmark client in the final tab. So let's go ahead and start up the scheduler. So the scheduler is responsible for receiving requests from clients. So this could be a SQL statement or a logical query plan created from a data frame API, for example, and the scheduler will take the query plan, turn it into a distributed plan, and then coordinate the execution of fragments of the plan against the executors. So now I'm going to go ahead and start up 2 executors. Obviously these will be listing on different port numbers because I'm running on a single system. These executors connect and register with the scheduler, which we see here. And now we can go ahead and run our client, which in this case is a benchmark that ships with Ballista, which is loosely based on the TPCH benchmark. So here I'm going to run query 12 against a partitioned Parquet dataset. So we see the SQL here. This is an aggregate query based on a join between 2 tables with some filters. If we go to the scheduler tab, we see some activity here. The scheduler is building up query plans and sending those to the executors. If we look on the executor tabs, we see activity on both of those. And let's see, so we see multiple partitions being executed in parallel, and results are being streamed out to disk in arrow IPC format. And then future query stages need to fetch results from previous query stages. So we see calls here to fetch partition. So this means that the executor is now streaming data from disk from a previous query stage and streaming it to the next executor or to the client. The other thing to point out here is that we see there's some basic statistics here. When a query stage is executed for each partition, we see the number of rows and batches written out, how long the query took, and so on. If I flip back to the client here, we can see that the results were fetched. So that query took 13 seconds. So that's a very basic demo, just demonstrating the mechanics of distributed query execution. Now obviously this is on a single computer, but the same principle would apply if we were using a Kubernetes cluster or setting up a standalone cluster on some EC2 nodes. We would need 1 or more scheduler processes, and then a number of executor processes, and then the client would send the query to the scheduler, which then coordinates the execution, and finally the client receives the results directly from the executors, and those results are actually streamed in parallel using the Arrow Flight protocol. So that concludes this basic demo. Thanks for watching.